Alright guys, so we'll continue on with our mini unit on similarity, and today we're going to be talking about proving triangles are similar. And so this is one of the big things of this mini unit is that you have to be able to prove whether or not two triangles are similar. And so to help us do that, we have a postulate and two theorems to talk about, and that's going to be the notes section. Then I'll show you some examples of how to actually prove they're similar. And then we'll do some finding missing sides, which you should be fine at if you understood what we did yesterday. Anyway, so the first one we have the angle-angle similarity postulate, and that's abbreviated AA similarity squiggle. Okay? And it says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So the first way you can prove is if you can just show that two angle pairs are similar. Or if you can show that two pairs of angles are congruent in both triangles, then that's enough to say that they are similar. So you could say, for this one, we would say angle A is congruent to angle D because they both have 1. And then angle B is congruent to angle E because they both have 2. So we say triangle ABC is similar to triangle. Now if I go ABC, I got to follow that same order in the second one. So I would say DEF. So we'll write the similarity statement, and then you'll tell me why we said they're similar. Okay? Second theorem is the side-angle-side similarity theorem. So SAS with a squiggle. And it says if an angle of one triangle is congruent to an angle of a second triangle, and the sides including the two angles are proportional, then the triangles are similar. Okay, so what that essentially says is you have this angle pair right here, and then you want the sides to be, you want the angle to be between those two sides, if that makes sense. So your angle needs to be between the two sides. So you'll have to check the proportions for your sides, and then your angle is going to be the same. So we can say that angle B is congruent to angle F. And now we're going to check sides. So I'm just going to start here with the first triangle because it's the first one I come to. And notice that 12 is smaller than 24. So I'm going to start with just 12. So 12 is the smaller one. And I need to match him up with the smaller one in the second triangle. Well, between 8 and 16, that's going to be the 8. And I need to see if I can reduce that fraction. So 12 over 8, you can reduce that, and that will reduce to 3 over 2. And we check the other pair, 24 to 16, and that will reduce, it also reduces to 3 halves. Okay, so these match. So we say that triangle ABC is similar to triangle. If I go ABC, ABC, then the second order has to be DFE by side angle side similarity. Okay, so make sure you check the angles congruent, and then you check both pairs of sides. If one of these fractions was off, like one of them was in 3/2, then we can't use side angle side. They would not be similar. All right. And then the last one is side, side, side similarity, or triple S, which says if all the corresponding sides of two triangles are proportional, then the triangles are similar. So now there's no angles to check, we just check all the sides. Okay? And of course, most times on a triangle you'll have a small, medium, big. So I like to go in that order. So in the big triangle, I'm going to start with the 8 because it's the smallest. And then I'll match him up with the smaller of the 3 sides over here. Well, that's going to be the 6. Can that reduce? And yes, it does. It reduces to 4/3. Now I go to the medium. So that's going to be 12 over 9. And again, that reduces to 4/3. It's looking good. Gotta make sure the third one matches, though. We can't just assume that it does. 16 over 12. And again, it reduces to 4/3. So all of these matched. So we say yes, triangle. I just like to do ABC first. I don't know why. Probably because I like order. Now, because I went A, B, C, I had to go medium, big, small. I have to maintain that in the second triangle. So medium, big, small. So that means I had to go D, F, E. And then this was by, side, 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 similarity. Oops, I didn't do that right. Similarity. Okay. So those are the 3 options you can use. You can use double A, side angle side, or side, side, side. Those are your only options. And when we start to do these problems, I have 4 to do. They will, where I gathered these from, the program that does it, they will prompt you to use one of the specific theorems, okay? So they will give you enough information that will make you think to use double A, side angle side, or side, side, side. Okay? So let's look at those. So we have to state if they're similar. If so, how do we know? And then we'll write a similarity statement if they are similar. So for this specific one, notice that we have 2 pairs of sides. So we have an S and an S. So automatically, I'm thinking in my head, which one of my acronyms can I use? I can't use double A because right now I don't know anything about 2 angles. And I can't use triple S because I don't know the third pair of sides. So by process of elimination, it has to be side, angle side that I need to use. And then the squiggle. But where does the angle come from, you're asking? Well, it's right here. Remember from part A of geometry when you talked about vertical angles, that when you had this X-ish shape going on, that the angles across from each other are congruent because they're vertical? That's going to come up sometimes with these, okay? So if you see an X, automatically mark it with the angle congruences, okay? I'm actually going to start with that angle. So I'm going to label that angle, and I'm going to be specific with its name, UDV. So UDV is congruent to angle, this would be FDE. just following that order. UDV, big, small, big, small. So I gotta go FDE. Okay, and that was because they are vertical. Okay, now I have to check my pairs of sides. So I've got my angle. Let's just start with the small side here in this littler triangle, 40. You have to match it up with the smaller side in the second triangle. Well, between 104 and 64, it's going to be 64. Now, does that fraction reduce? You can use alpha y equals to type that in. Oops, I can't do it right. 40 down 64. Oops. 4 equals. And then it gets 5/8. So it reduced to 5/8. And now we check the other two. So 65/104. Do the same thing. 65/104. And it's 5/8 again, which is a good thing. So these matched. So I got my sides. So we say, yes, they are similar by side, angle, side, similarity. Barely see that. So you have to tell me yes or no. And then if it's yes, you tell me which theorem you used to prove it. And I need to see this work of you trying to prove it. Now I write the similarity statement. So I'm going to start with the second triangle. And I'm actually going to cheat and kind of use this one right here. I can trade out the angle sign for the triangle sign and use that same thing. So I'm going to say UDV, similar. So instead of congruent, use similar. And then similar to triangle FDE. All right. Next one. Notice I have all the sides here, all the sides here. That's your cue to use side, side, side similarity. Okay? Because you know all three sides. And so I'm just going to start pairing up. I like to start with the small one. So 10 is the smallest. And who's the smallest down here? That's 35. And if you use alpha y equals to reduce that fraction, it reduces to 2/7. And we repeat with the medium pairing. So 16 medium over 56 medium. And you reduce that, it gets 2/7 again. And then 18/63. And if you reduce that, it gets 2/7 again. So every one of these worked. So we're going to say yes by side, side, side similarity. And then we write the statement. So I'm going to start with this first one. And let's say I go with EDC. That takes me from small to medium to large, going in that order. If I do this order, then I have to maintain that in the second triangle. So small, medium, big, small, medium, big. That means I have to go TSR as my statement. And you could do any order you want to here, okay? Just remember, the way you write the first order determines how you write the second one, okay? So let's just say another possibility here you could go alphabetical order if you want to for the first one. CDE if you wanted to. But if you go CDE, that's medium, small, large, passing through the sides. So you need to go medium, small, large. So that would be RST. So this is one example. And this is another one. And of course, there's a third one, but I'm not going to do it. All right, so let's go look at two more of these. So, same process. Now, looking at this problem here, all I see is one angle pair marked. So, thinking about my acronyms, if I see one angle pair, then I know it has to be either AA or side angle side. And then if I look at that a little bit more, I realize that, hey, there's no sides marked. So that is my cue that it should be AA. And we know we have the first A. We have angle R is congruent to angle E, because that was given to us. Where's the second angle pair come from? Well, look a little bit closer. We see another X, and we know that that pair is congruent, those two. Now, I want you to specifically name them for me. So we're going to say angle. Let's just say I go with SQR. So SQR. Maintain that order, I would have to do DQE. And that's because these are vertical. And this one was given. So we have fulfilled that. So yes, they are similar by angle similarity. And then again, I'm going to use this statement here and just adjust it for similarity. So similar. And then if you're going to do what I did, make sure you take the angle symbol out and put the triangle symbol in. Okay? All right, one more of these and then we'll do some finding missing sides. So, looking at what they gave me, I see an angle pair that is caught between two pairs of sides. So that is my cue that they want me to use this one. And so we said, let's start with the angle. Angle M is congruent to angle T. So I have the angle pair. Now I'm going to check my sides. So I'm going to start with the smaller of the two. So 12 matches up with 53 in the bottom one. And that doesn't reduce, so I'm just going to leave it like that. Now we'll check the other pair. So 21 over 91. Does that reduce? I don't know, so let's go see. 21, 91. Uh-oh. 3 over 13. These don't match. So, are they similar? No. Not similar. And that's because the sides are not proportional. You could say that. So, remember, if one of your fractions fails, it's all off. No, not similar. All right. These two should be kind of easy because we sort of did this yesterday. You set up a proportion, so fraction equal fraction, and then you cross multiply and solve. So this should be okay, I would think. Now, this specific example, I had to think about for a minute because I set it up two different ways, and then I had to think about it. And here's, okay, I'm rambling. So do y'all see in the second triangle that the side labeled 9 and labeled 10, the 10 is just barely bigger. I mean, if you actually look at the length, the 10 is barely bigger. You have to, and I'm saying this because you have to match up the sides from here to here correctly, or else it throws the whole thing off. It shouldn't be a decimal, the way I've got it made. And so if we look up here, the side they want is this one, and it's just barely longer than this one, the 18. So that tells me that the 18 and the 9 go together because they're the smaller. So I'm going to do 18 over 9. And because I did 18 first, I'm going to put that one on top. I'm going to call it x over 10. Now, if you want to do backwards, if you want to go 9 over 18 first, and then do 10 over x, that's perfectly fine. I don't care how you set this up, as long as it's set up correctly. There's different ways to do it. Now we're going to cross multiply. So I like to put the x on the left. So the x times 9, so 9x equals 18 times 10, which is 180. And then just divide 9, x equals 20. Oh, hang on, I'm getting a phone call. All right, sorry about that. Got a phone call. That's all you do. Set up your proportion, cross multiply, and solve. And we're going to do that every time. All right. So same thing here. I'm going to start, it doesn't matter where you start. Let's just start down here with 18. 18 is definitely smaller than this one because of the length. So 18 is going to go with the smaller of the two up here, which is 42. So 18 over 42 equals x over 63. Okay? You can sort of think about this as far as matching the sides up as matching up sizes, if you will. Like 18 and 42 are the smaller sides of their respective triangles. So that's why they go together. And then the x and 63 are the larger of the two, so they go together. That's how my brain thinks about it. All right, we'll cross multiply. 42 times x is 42x equals 18 times 63 ends up being 1,134. Now we'll just divide by 42. And you divide that and you end up getting 27. Okay, last two. This video might be a little bit longer, but you can always pause it and copy stuff down if you need to. All right. Now, you can also do these similar triangle problems where the triangles overlap each other. And I wanted to show you those because they can be a little harder to understand for some kids. So for me, I sometimes go to where x is at, like where the unknown is at in x. And I look at who matches up with it. So this x is representing this entire length right here from F to G. Well, who does that match up with in this smaller triangle that's set right here? Well, it's the 44 because they're both on that same left-hand side. So we can put those together as x over 44. And then we have to maintain this order. So I went from the big side to the little side. So keep that order the same. 66 over 24. And I will solve. So cross multiply. X times 24 is 24x. And then 44 times 66 is 2,904. Divide by 24. X equals 121 when you do that division. All right, last one. Let's go to the x first. So x is from L to M. That corresponds to, looks like the 72. So x over 72 equals, now in this instance, you could actually set it up a different way. You could do, let's say, we did the x first, so that means I gotta start with 98. 98 over 84. Or x over 72 equals, start with the big one, so 77 over 66. You could do either one of those. Okay, I'm going to solve the left one because that's what I went with on my paper. So x times 84, 84x equals 72 times 98 is 7,056. Divide 84, divide 84, x equals, and it ends up being a perfect 84. Okay? If you chose to set it up this way, your work will be a little bit different, but you should end up with x equals 84. And all right, that's it. So that's proving triangles similar. So make sure we watch this all the way through, and then we complete the homework assignment. And as always, if you need help, please let me know.